Hey, sixth grade, believe it or not, we actually finished your textbook. So we are going to be moving on to the seventh grade textbook. That is why you see here, I've started a new page. It says Chapter 1. And at the top of the next page, I have put Chapter 1, Section 1. And we're going to start talking about rational numbers. Now, as we go through the seventh grade text, as we start to go through it, you might see topics that we did cover in your sixth grade textbook, but they kind of go a little bit deeper into the topics themselves. So it might be the same thing, but you get a little more coverage on them, if that makes sense. So before we get started, we do have a little bit of vocab that we're going to talk about. So that's what I'm going to start with first. And we're going to start talking first about what is a rational number. So a rational number, very simply, can be written like a fraction. Now when I say fraction, I mean you have some number over another number. So A over B, where A is a number and B is another number. Both A and B must be integers. And B is not allowed to be 0. Not allowed. So B cannot equal 0. Not allowed to. If it does, you're dividing by 0, and you can't divide by 0. It is not possible. So, what is an integer? Let's remind ourselves, integer, what that is. An integer is a set of all positive numbers, their opposites, meaning negative numbers, and 0. Whoops. And 0. So that is what integers are. Now, when you have a rational number that's set up like a fraction, sometimes you're going to have, if you're trying to turn it into a decimal, you can have it be a repeating decimal or a terminating decimal. So a terminating decimal, I'm not spelling this right. Terminating. There we go. Decimal. I have to sound it out. A terminating decimal is gonna be one that stops at some point. It stops or terminates at some point. It could be in the 10th place, in the 100th place, in the 10 millionth place. It doesn't really matter where. It just has to be able to stop at some point in order for it to be considered a terminating decimal. Now, on the other side, it's exact opposite. You have what is called a repeating decimal. Okay? That means you have the same digit or group of digits going on forever. So for example, you might have 0.5 repeating. That's what that little bar means, repeating, going on forever. You might have 0.36 repeating, goes on forever. You might have 0.7329 repeating. It's a bad repeating bar. I apologize for that. But you get the idea. It can be one digit, it can be two digits, it can be a whole bunch of them, but it's got to be the same pattern. So this would be 0.7329, 7329, 7329, 7329, 7329, 7329 forever. And it will always follow this same pattern. If it doesn't follow a pattern, it is a non-repeating, non-terminating decimal. You know what? Let's put that in. non-repeating, non-terminating. What am I spelling? All right, non-repeating, non-terminating. There's no pattern, never ends. An example of this would be pi. Pi is a non-repeating, non-terminating decimal. It goes on forever, but there's no pattern to it. So if it's non-repeating and it's non-terminating, it's not a rational number. Okay? If you have either of these two going on, terminating or repeating, then it's rational. If you've got this going on, not a rational number. All right, so let's go ahead and try a couple of these. Let's see an example of a terminating decimal. Terminating. Why am I having such trouble with this word? I don't know. Okay. So let's do 36/125. That's a nice one. All right. So we are going to go ahead and turn this into a decimal. Easiest way to do that, top, divide, bottom. Excuse me. So top, divide, bottom. I'm going to set this up in a division bracket. Just like that. I extended this for a specific reason. Now, 125 is not going to fit into 3. It's not going to fit into 36. So what I'm going to need to do, I'm going to put a decimal point in my number and up in my quotient. And I'm going to put a 0. And I'm going to treat this as if it were 360, because 125 will fit into 360. It's going to go in 2 times. So that would be 250. I'm going to subtract, and I get 110. 125 is not going to fit into 110, so I'm going to bring down my next number. If you have a whole number, after the decimal point is zeros forever. So you can always pull down another 0. So 125 will fit into 1,100. That's going to go in 8 times. And that's going to equal a nice even 1,000. So when I subtract, I get 100. And I'm going to go ahead and pull down my next 0. And it's 1,000, I already know, goes in 8 times. So once I'm done, I get a nice big 0. I don't have to pull down anything else because I'm done dividing. So 36/125 as a decimal is going to be 288 thousandths. 288 thousandths. So this is an example of a terminating decimal. It did stop at one point. We also know that this happens to be a rational number because you can see it's already written like a fraction. So we're good to go. Let's try another one. This is going to be an example of a repeating decimal. This will be number 2. This is going to be a repeating decimal. And let's do 27/99. Yeah, sure, that's a good one. All right. So, in order to turn this into a decimal, we do the same thing as we did before. Top, divide, bottom. So if I set it up in my division bracket, 27 should be on the inside. It's the dividend, and 99 is my divisor. So 99 is not going to fit into 2. It's not going to fit into 27. So I'm going to put my decimal point here and up in my quotient. And I'm going to go ahead and put the 0 right after the 27 because 99 can fit into 270. I'm going to treat this as 270. It's going to fit in 2 times. It's going to be 198. I subtract, borrow, I'll get a 2, borrow, 7, and that's a 0. Okay, so I got 72. 99 cannot fit into 72, so I'm going to go ahead, grab another 0, bring her on down. It can fit into that. I will tell you it's going to go in 7 times. I'm going to get 693. I'm going to go ahead and subtract. I'm going to borrow 10, 7. That is going to become 6 and 11, 2, and that's a 0. Okay. So 99 is not going to fit into 27. I bring down the next one. That's going to go in twice. Oh, I'm noticing a pattern here. I'm just going to finish this out here so you can get at least one repetition of the pattern. Once I subtract, I get 72. Bring down the next 0. That's going to go in 7 times. You can kind of see where this is going. I get 27 and the pattern is starting over again. So when I'm going to draw this with a Repeten bar, I only need to draw it over where it starts to repeat itself. So I could do this, 2, 7, 2, 7, and draw a Repeten bar. But that's the exact same thing as this. Okay? You only need to do it up until it's different, and then it starts to repeat itself. So 2, 7, then it goes 2, 7, 2, 7, 2, 7, 2, 7, 2, 7. I only need the repeating portion, one repeating portion underneath. You can see here, I've got like 2 separate ones. I don't have to do that. I can write it like this. So there you have repeating and terminating decimals. Now, one more thing we're going to do in this section is talk about how to turn, and we have talked about this before, you guys know how to do this, how to turn a decimal into a fraction. So we did fraction decimal, which is what we did in, number 1 and number 2. Now we're going to go the other way, decimal to fraction. So let's start off with something nice and easy. 0.345. All right. We're going to turn this into a fraction. All right. So this is a rational number. How do I know? Well, it is a terminating decimal. If it is a terminating decimal, as this one is, then it is a rational number. And I should be able to turn it into a fraction. So, easiest way I have found to do this is to say it out loud, because that will tell you what number you need to put it over. So I'm going to say this correctly out loud. 345 thousandths. Let me say that one more time. 345 thousandths. That means 345 over 1,000. Which is fine. That is, in fact, a rational number written as a fraction, but it's not in simplest form. So we're going to go ahead and turn it into simplest form. So let's divide by, let's do 5. Divide by 5. I'm going to get, let's see, it's going to go in 6 times, bring to 4, that'll be a 9. And I know that if you divide by 5, you're going to get 200 here. And I think that's it. Can I divide anything else? Nope. Nope. That is simplest form. Okay. I only had to do one bit of division. That's good. Alright. So, as a terminating decimal, it is a terminating decimal. As a rational number in fraction form, 345 thousandths equals 69 200ths. Let's try another one. Actually, we might do 2 more. We'll see. This one's going to be a mixed number. Okay? So we have 1 and 85 hundredths. 1 and 85 hundredths. I'm going to save the 1 for just a minute. I'm going to leave it be. And I'm going to go ahead and just deal with the decimal piece for now. So again, say this out loud. 85 hundredths. 85 hundredths. And let's go ahead and turn this into, or sorry, it is a fraction. We're going to reduce the fraction. There we go. This would be 17 over 20. So 1 and 85 hundredths is 1 and 17 twentieths. Now this is technically correct, but remember what I told you about rational numbers? That a rational number is always some number over another. It doesn't say anything about there being a number out front. So in order for me to turn this into a true rational number, it's got to be an improper fraction. So I'm going to go ahead and turn this into an improper fraction. Remember how to do this. You take the denominator and multiply by the whole number. Then you add what's on top. So 20 times 1 is 20. Add 17. I get 37 twentieths. So 1 and 85 hundredths is the same as 37 twentieths. This is correct, but in order for it to be actually a rational number, I've got to write it as an improper fraction. Let's try one more like that. Let's do one more. Okay, let's do 5 and 244 thousandths. All right, so leave the 5 alone for right now, and let's just deal with the 244 thousandths. 244 thousandths. All right. I'm going to go ahead and divide by 4. Okay, 1,000 divided by 4 I know is 250. Let's see, 4 goes into 24 6 times, nothing left over, so it would be a 1. Ooh, 61 I think is prime. Why do I keep picking these numbers? That's okay. Alright, well, we only had to divide by 4, and we got 61 250ths. So that would be 5 and 61 250ths. But again, remember, in order for this to be a true rational number, it's got to be an improper fraction, because it's got to be some number over another number. It doesn't say anything about having a number out front. So I'm going to take 250, multiply by 5. That would be 1250, and add 61. Let me do some math off to the side here. 1250 and 61. 1, carry the 1, 3. There we go. So it would be 1,311 over 250. So 5 and 244 thousandths is the same as 1,311 250ths. Woo, that is a mouthful. Alright, so I'm going to have you stop there, and you're going to head on over to Excel and practice these skills there.